Magnetism. The first known magnets were the pieces of lodestone, an iron ore of iron oxide found in large quantities in Magnesia. The Chinese, earlier than 2500 BC, used these pieces to guide their boats. The pieces of lodestone found in nature were later on called the natural magnets. The word magnet has been derived from Magnesia, and here it was found in Asia Minor. This ore was found to possess two property. Number one, it attracts small pieces of iron, and number two, it sets itself along a definite direction when it is suspended freely. The natural magnets are found in quite irregular and odd shapes, so they are not magnetically strong enough for use. They are of different uses. Therefore, artificial magnets were prepared in different convenient shape and sizes, such as bar magnet, horseshoe magnet, magnetic needle, and magnetic compass. If a magnet is suspended with a silk thread such that it is free to rotate in a horizontal plane, it sets itself always pointing in the geographic north-south direction. And the law of magnet is two poles repel each other while two unlike poles attract each other. Now we'll go to induced magnetism. When unmagnetized bar AB of a magnetic material such as soft iron or a steel is placed near or in contact with a magnet as shown in the picture, the bar AB becomes a magnet because it acquires the property of attracting iron fillings when they are brought near its ends. If a magnet is now removed, it is seen that nearly all the iron fillings will start dropping down which was clung to it. Thus, the bar magnet of a magnetic material behaves like a magnet. So, as long you keep near in contact with a magnet, the magnetism is produced. Therefore, the temporary magnetism acquired by a magnetic material when it is kept near a magnet is called induced magnetism. The process in which a pieces of a magnetic material acquires the magnetic property temporarily in presence of another magnet near it is called as magnetic induction. Here, a magnetic pole induces an opposite polarity on the near end and the similar polarity on the farther end. Therefore, induction produces or precedes attraction. Induction magnetism is temporary. Next here, lines of magnetic field. The space around a magnet in which the needle of a compass rests in a direction other than the geographic north-south direction is called magnetic field of the magnet. Magnetic field is a vector quantity because if magnet is placed or magnetic compass is placed on a table, it is found that its needle rests in geographic north-south direction. Now, if we place it near a magnet, the needle starts swinging and then rests in some other direction. As the compass is placed at different position around a magnet, the direction in which the needle rests changes such that one end always point towards the nearer pole of the magnet. This behavior of the needle is due to the influence of magnet near it. This region in which the compass gets influenced is called magnetic field of the magnet. Now you can see in the picture, when you compass needle is placed at any point in a magnetic field, its needle rests along the magnetic field line. An arrow is marked on the magnetic field line from south pole of the magnet or the needle to its north pole. This arrow indicates the direction of magnetic field at that point. Therefore, magnetic field line is a continuous curve in a magnetic field such that tangent at any point of it gives the direction of the magnetic field at that point. Next, properties of magnetic field lines. Here we have some of the following properties. Number one, they are closed and continuous curves. Outside the magnet, they are directed from the north pole towards the south pole of the magnet. Number 3, the tangent at any point on a field lines gives the direction of a magnetic field at that point. Number 4, they never intersect one another. If two magnets or field line intersect, there would be two directions of the magnetic field at that point, which is not possible. Number 5, they are crowded near the poles of the magnet where the magnetic field is strong and are far separated near the middle of the magnet and far from the magnet. Parallel and equidistant field lines represent a uniform magnetic field. The Earth's magnetic field is limited in a space is uniform. Number 7, they behave like the stretched elastic rubber string. And you can refer 195 page to go through one more time all the properties.